Hi class, welcome to video 1 of this stepper motor demonstration. You see here I got a stepper motor ready to go to demonstrate. We're going to maybe turn the camera off for just a little bit and get started talking about a couple things. First off, the reason for this video is because the components that come in your kit, the motors are pretty simple and not very strong, and so I find a lot of students want to use stepper motors and just really don't know how to use them or wire them. What we'll talk about today are some basic principles that apply to any stepper motor, but I'll focus primarily on motors that we could use in the class or you could purchase from, let's say, a project or something. So to get started, we're going to use a NEMA 17 motor, and if you're interested in purchasing a NEMA 17, you can just go to Amazon and search NEMA 17 stepper motors, and you can see there's quite a variety that you can purchase from. They're range in cost. One thing I wanted to point out was notice how all of the stepper motors, the faces of them look the same, and that's because the NEMA 17 gives the dimensions of that face. And so when you ask for a NEMA 17 motor, you're getting this consistent face. In fact, if I look at some specs of a stepper motor, a NEMA 17, you can see that they have 42.3 millimeters, I guess, square, and then the whole pattern is 31 millimeters, and they have M3 screws. So anyway, it's pretty consistent shape for NEMA 17, for at least for the cross section. And the lengths, notice that there's different lengths for the stepper motors. For example, this one, it's a pretty short motor. It's a 0.16 Newton meter torque. But if I get a longer one like this, then you can see it has a 59 Newton centimeters or a 0.59 Newton meters. So you can see this one's much weaker in torque than this one. We could probably find some other different lengths. For example, here's one that's a 760 millinewton meter. So that would be 0.76 Newton meters, or 76 Newton centimeters. So that 76 is even a little bit stronger than these. So different lengths give different strengths or different torques. You can also get some that have built-in motor controllers. We'll talk about what motor controllers today, at least one in particular right now in this video. But having a built-in motor controller just kind of simplifies things. It does increase the cost quite a bit, but you can get those pretty easily. There's some that come with lead screws. You can see here. So as this turns, this collar will slide back and forth, kind of like thinking of raising the bed of a 3D printer or something. There's other types. Let's see if we can find one here that are geared. Let's just search for one here. So gear, and here's one, for example. So now this stepper motor has a 5-to-1 gear ratio built into it. There's many other times. Here's a 10-to-1 gear ratio. I think I've seen 100-to-1 before. Here's a 27-to-1. So if you need more torque for your application, then you can buy a built-in gearbox that'll convert it. So in this one, it'll be 27 times stronger in torque, but 1/27th of the speed. So it'll be a bit slower. So anyway, quite a variety that you can purchase simply on Amazon. If we go to kind of a more reputable source, I guess, Stepper Online, I guess, is a producer of some stepper motors. I can go to Stepper Online and then search for hybrid stepper motors. You can see here they also have geared, closed loop. This means they have, that controller like the one we saw on Amazon, but you control the position and it'll actually sense its position and move to that desired position. Anyway, a variety of different kind of stepper motors. But if we just look for hybrid stepper motors, those are kind of the most basic. You can see first thing right off the bat, quite a selection that we can choose from. First is frame size. Notice NEMA 17 right here, 42 by 42 millimeter. So there's very consistent. We can go to other frame sizes, 60 by 60 millimeter, NEMA 23, NEMA 34, 86 by 86. So different cross sections, again, will give different torques and speeds. If I just select NEMA 17, like our others, and I'll minimize this, you can see now I have a couple options for step angles. Pretty common step angle is 1.8 degrees. So 360 degrees divided by 1.8 is 200 steps per rotation. So this motor would have take 200 steps in order to complete one full revolution. Or you can get twice the resolution by having one that goes 0.9 degrees. Different stepper motors will have different angular resolutions. These are common ones for NEMA 17. Let's just pick the 1.8, I guess, if we want to. Now, output shaft type. Most common is a D-type, where the D-type looks like it's got this flat spot on the shaft, where that provides, instead of a just consistent circle, you have a flat spot, so that way it can transmit torque to whatever surface, or you could put a collar on here and have a flat spot to push and drive a set screw for torque transmission. The O-type is, again, just this solid circular type. And hollow, those are interesting. Hollow types, what these are, if I click on this, for example, and maybe look at across, you see the shaft goes all the way through the stepper motor and both sides is hollow. So what that is if you can have a stepper motor where, let's say you need a wire running down through the middle, or it's attached to something that you need to transmit in the liquids or gases or something like that. The hollow type allows you to do that. So if I go back and unselect the hollow type and get the D type, the most common, other options you can select are bipolar and unipolar. A bipolar stepper motor means that the coils within the stepper need to have power going in both directions through that coil. So, for example, let's go back to that spec sheet here. This stepper motor, this NEMA 17, is a bipolar, okay? And if we look at the coils, there's two coils in that stepper motor. And in order to make this stepper motor move, at some points in time, the black wire, which is one end of the coil, will need to be positive and the green will be negative, so current will go from top to bottom here. And then another step in the sequence, that will be reversed. Green will be positive and black will be negative, so the current will go up in this diagram. So a bipolar motor requires you to move those, be able to control the currents in both directions. So it's a slightly more complicated motor controller. If we select a unipolar type, and let's just go maybe to one of these here and open I keep getting these Chinese New Year things, and look at the spec sheet. Let's do that. Yeah. Here's a spec sheet for a unipolar. And you can see the unipolar, this motor can be wired such that it's in unipolar or bipolar. Notice in the bipolar, again, you have plus and minus. These have to reverse directions of current in either direction. A unipolar, what this would do is this could be given either 5 volts or ground. But in both cases, if this is, let's say, 5 volts here and 5 volts here, then all you have to do is wire A plus to ground, and current will go this way, and then turn that off and then wire A minus to ground, and current will go that way. And current, if this is always connected to 5 volts, then current will always go from here to A plus. It'll always go in one direction. So that's a unipolar, meaning you can wire it in such a way that current will always go in one direction. the stepper motor that comes in the Arduino kit is a unipolar motor because it's wired just like this. There's a common 5 volts to the centers, and then the other 4 wires that are connected to ground at certain times in order to get the motor to step in sequence. So that's an example of a unipolar stepper motor. So, if we select a bipolar, now you can get some spec sheets like, let's say I do want the torque thrust curve so I can get some better data from it, and then now I can maybe range for what size holding torque do I need, length, for example. So notice here, if I get a shorter length, it's going to cut down on my available torque ranges. And then if I go select, there's other options. So you can select different diameters of shafts and lengths. And yeah, so you can customize your motors, end up picking something that works for you. That's it. And then, yeah, if you select this motor, I gotta click this. Yeah, don't show you. If you can get the specs off of the motor, then these would be really helpful for you. One spec in particular that's helpful is the resistance. Here it is, phase resistance. So if this motor has, each coil has 6.3 ohms, and let's see, does it give me the voltage rating of the motor? I don't think I saw the voltage rating. Its rated current is 0.85 amps. But let's see here, description. I didn't see. Let's say I power this. I still don't think I see it. Let's say I power this with like a 12 volt power supply. Okay. So if I power with 12 volts and each coil has 6.3 ohms, right? And 12 volts divided by 6.3 from Ohm's law gives me 1.9 amps going through each coil. Okay. And that's about twice, what this is. So we got to be careful. We couldn't give it with 12 volts. What I could probably see is, okay, given the allowable amps and the resistance and the allowable voltage, 6.3 times 0.85 amps means I could power with 5 volts. Yeah. The stepper motor I'm going to demonstrate today, you can see has a resistance of 1.4 ohms. Okay, so that's not very much. And so we got to be careful because it's such a small resistance that it can get really hot. We're going to draw a lot of current. For example, with 1.4 ohms, if I power that with 12 volts, it can draw almost 8.5 amps when I'm powering it. And so I need to make sure I have a power supply that can handle it's 12 volt, 8.5 amp at least, in order to power the stepper motor. So these are some of the considerations to have when you're buying a stepper motor. And you don't always get these specs when you purchase them directly on something like this from Amazon. Sometimes you just get some basic information. Better ones will hopefully give you some better details. For example, they say it's rated for 12 volts. I guess its rated current is 2 amps with a resistance of 1.4 ohms. Well, I wouldn't give it 12 volts then, because again, 12 divided by 1.4, right, is 8.5 amps, but this says it's rated for 2. So you'd have to be careful if you power the 12 volts. Make sure you don't sit it and engage it and power the stepper for very long, because you could, it could get really hot. So anyway, those are some considerations to have when you're purchasing and using stepper motors. Okay. Let's see. Okay, looking more at this data sheet, what we want to consider is now how the stepper motor works when it operates. So we have a bipolar stepper motor, and we have 2 coils. And when we energize each coil, then the rotor is going to want to align the teeth on the inside. And this is a pretty good picture right here. Notice how the teeth on the inside want to align with different, see, these are aligned right now. If you power certain coils, then they'll want to align. So if we alternate which coils are being powered, those teeth will move to be aligned with other coils. So what we need to do is figure out, okay, how do we power this in order to get those teeth to line up and rotate in a certain direction and keep rotating? Well, that's what this diagram is for. So first off, notice we have black, green are connected together. And if we look up here, black and green, black is considered A+, green is A-. So these are connected together, and then red and blue are connected in the same coil, and that's considered B+ and B-. So we have an A coil and a B coil. And if we power it in such a way, and we sequence through certain steps, we'll get it to move in a certain direction. So, for example, in step 1, if we want this to rotate in a clockwise direction, then I need to rotate it from step 1 to 2 to 3 to 4. So in step 1, I would power A+ and B+ with positive. So that would be the black and the red with positive, and the A- and the B- with negative. So that would be the green and the blue. So current will be going down and then to the right. Then the very next step, what we do is notice that the B's are the same, but the A's switch direction. So that means current's still going to the right down here, but we've reversed direction on the A coil, so now current's going up. And then going from step 2 to 3, the A's stay the same, and then the B's flip direction. So now the current is going up and then to the left. And then going from step 3 to 4, we keep the B's consistent again, so current's going to the left, and then we flip the direction of the A coil, so now current's going down again. And then now that I've rotated through 4 steps, I go back again to step 1, and then you can see in step 1, from 1 to 4, A stays the same, and then B is reverse direction. So now current is going down and to the right again. And you keep cycling through that sequence and then get the stepper motor to rotate clockwise. And to simply rotate the opposite direction, all I have to do is follow that sequence backwards, and then it will rotate the opposite direction. So what I'd like to do is kind of demonstrate that. But before we do, let's first, I think I made a simpler diagram. Well, I think it's simpler, but this sequence, I like having the A's together and then the B's together. And then you see step 1, 2, 3, 4. And then I coordinated the color of the wire. So A is black, A- is green, B+ is red, B- is blue. And notice from step 1 to step 2, B's stay the same, but A's reversed. And then step 2 to 3, A stays the same, but B is flipped. And then 3 to 4, B stays the same again, and then A is flipped. And then going back from 4 to 1, A is consistent, and then B is flipped. So we're just rotating through that sequence, okay? And what I like to do is wire that to an L298N stepper motor driver. Well, I shouldn't say stepper motor driver. It's really more of a, just kind of a permanent magnet DC H-bridge. And these are pretty cheap to find. The reason I recommend these is just because they're so easy to find. There's better ones out there. But this is just too easy to not use, I guess, in reference. So if you just search L298N on Amazon, you can see there's just a huge variety of, well, not variety, but I guess buying options. And fairly inexpensive. Okay, really what they're meant to do is to power one DC motor on each side. So these two pins right here will power one permanent magnet DC motor, and then these two pins will power a different DC motor. Well, the stepper motor is 2 coils, which is like having two motors, so we just wire both of them to here. And then the front of the motor controller has these 3 pins. Underneath will be written VN, ground, and then 5 volts. And the VN is the voltage you want to give to the motors. Ground is the ground from the power supply, which you also need to connect to your Arduino. And then if you power this and leave this jumper connected, this will convert that whatever voltage to 5 volts that you can then send back to power your Arduino. So with one, let's say 12 volt power supply, I can just plug it in here and get 5 volts out of here, and then I can plug it in and power my Arduino. These pins right here are what control the direction of current through these coils. So these 2 pins here will control direction of current on this coil over here. These 2 pins will control the direction of the coil that's wired to this guy over here. And so if this is positive and this is negative, current will go one direction through coil A. If I flip that, current will go the opposite direction. So it's a pretty simple, easy way to control the stepper motor. It's low cost, so that's what we're going to show here. So if I take my stepper motor, first again, I have my A coil, which is A plus was black, and then A minus was green. And then my coil B, my B plus was red, and my B minus was blue. Okay, and then I have my 12 volts, let's say. So I have a 12 volt power supply, and it comes with this cool adapter that I'm going to use. So I can just directly connect the power supply to these wires through the screw terminals and connect 12 volts and then ground. And then I can connect ground and 5 volts to my Arduino to power it. And then I am going to connect my pins, digital pins 2, 3, 4, 5, to these ins in 1, 2, 3, 4 to control the stepper motor. So I'm going to do that, show you that real quick here. Let's turn on the camera and go full screen mode here for a second. So I got the stepper motor with a little pointer on it, kind of just makes it easier to spin. It's actually got a flat spot right here, so it's the D type, okay, NEMA 17. And you can see the 4 wires here, and I've wired them such that I got A plus and A minus, and then B plus and B minus right here. And then my power supply, I got my 12 volts and ground going to my 12 volts pin and ground. I'm not using this 5 volt connector because I don't want to connect to the Arduino because I'm going to power it from my computer. So I'm going to leave that separate. However, I do need to make sure the ground is still connected from ground to ground on my Arduino. Otherwise, when my Arduino outputs 5 volts, it needs to be referenced to the same ground as what this is expecting is 5 volts. So that way, if my ground's connected, they have the same reference point. So that way, 5 volts here looks like 5 volts here on the motor controller. Okay. So again, this is the H-bridge board L298N. You can see the silk screen on the bottom kind of describes a little more. Okay. So before I run that, we're going to talk about a little bit of code first. So I'm going to minimize that here, and let's go talk about some Arduino code. In fact, I'm going to minimize this, minimize that, move this over here. Let's see. Let's talk about first number 1 code. So in this code, which I'll provide with the video, with the assignment in Canvas, here's the code. So, and again, it's got the wiring diagram on here, how the step sequence goes. It's written for 1.8 degree per step or 200 steps per revolution. I wire it to the L298 by having these wires, black, green, red, blue, to these out pins. So, and then I wire the in pins on the L298 1, 2, 3, 4 to digital pins 2, 3, 4, 5. And then I make sure I power. I don't think I'm going to do this one. I used to do that. I'm going to take that off. I'm going to connect ground to ground. Okay. And then I power the L298 separately. Okay. Now in this code, I'm just going to define a couple variables first. So I want it to rotate twice, and there's 200 steps per revolution. I decided to use a delay of microseconds, And this, I'm just kind of teaching you something new. There's a delay. Instead of just using the regular delay, you can use delay microseconds. That's kind of new. So this is really using a delay of 1 millisecond. And then I decided to call my pins, the 2, 3, 4, 5, A plus, A minus. I called AP and AN, and then B plus and B minus is BP and BN. And then in my setup, I just set those pins as outputs. So digital outputs, I turn them all off, so that way the motor starts off. And then I made a function down here to rotate through the step sequence. So if I call this function, I say, give it the number of steps. So if I want to go 2 rotations and 200 steps per revolution, I'm passing a value of 400. And I want a delay of 1,000 microseconds or 1 millisecond in between each step. So now this function I pass here, so I get a value of 400 and a delay of 1,000 microseconds. And so if n is positive, then I want to rotate in a clockwise direction. So here's the first step. And I think I closed that, didn't I? Oh, no, right here. So if I take this to the side here and zoom a little bit. So step 1 was A plus was plus, A minus is negative, B plus is plus, B minus is negative. So here's plus, minus, plus, minus. So there's that first step. Then I delay 1,000 microseconds. Then I go to step 2. So minus, plus, plus, minus. So minus, plus, plus, minus. So I'm just stepping through those 4 steps right here. And that's all I do. And then I increment. I go from 400 steps down to 0 in increments of 4 because, right, there's 4 steps in each of this loop. If I happen to pass a negative number, that means I just want to rotate in the opposite direction or counterclockwise. So I just go through the step sequence backwards. So this would be step 1, then step 2, step 3, step 4. So I start with step 4, then go 3, 2, 1. So it'll go backwards. So it just spins in the opposite direction. So that's the code. And then after I go through those sequences, I turn everything off to make sure the motor doesn't overheat. So I'm going to move 2 rotations clockwise, wait a second, and then move in the counterclockwise direction. And then because this is in the setup loop, it'll stop. The void loop is just doing nothing. That's pretty mean of me, but that's what's going to happen. So I'm going to program or upload this to the Arduino. It's done compiling, done uploading, and then I'm going to make this full screen. Okay, I haven't powered this yet, so I'm going to power it. I got a 12-volt power supply with, let's see, it's a 10 amp. So 12 volts, 10 amps, so definitely more than the 8.5 needed to run this. So it should be powerful enough. Now I upload this, so the code has probably already run through the setup. So it's not going to do anything when I plug this in. You can see now my L298 is powered, the LED is on. So all I have to do is hit the reset button and this will spin, okay? And so I'm going to put this right here so you can see. That way we can tell it's making 2 full rotations. So I'm going to hit the reset button. It should go clockwise twice and then counterclockwise twice and stop. There we go. So pretty simple. Again, all you have to do is go through that step sequence and then you can get your motor to rotate as you wish. Okay, now let's minimize this and let's look at a different code. This is neat, but this is kind of annoying. There's a lot of digital writes, and it's just, I don't know, to me it's just not fancy enough, I guess. So what I'm going to do is I'm going to go to a second code here that I'll also provide. Same thing, wired the exact same, except for now what I'm going to use is called port manipulation. So what port manipulation is a fancy way to turn on and off digital pins all at once. So with this port D command, I can command the digital pins 0 through 7 in one step. And I have to give it a binary number. And so if I just give it a 0 for the pins that I want low and a 1 for the pins that I want high, then it'll do those digital writes, all of them at the same time. So if I go through step 1, again, I want pin, this is pin 2 here, so pin 2, 3, 4, 5, I want 2 and 4 on. So you can see here I have pin 2 on and pin 4 on. Okay, and now all I have to do is say, okay, let's take that binary number, convert it to decimal, and doing so I get 16 plus 4 equals 20. So I can just say, hey, step 1 is equal to 20. I don't even really have to do these 2 steps. I can just leave it at this. I don't know why that bothers me, but I could probably demonstrate and make sure that works here in a little bit anyway. But so step 1 has a value of 20. Step 2, I wanted pins 2 off, 3 and 4 on, and 5 off. So pins 3 and 4 are the only ones on. And so converting that to decimal, that's 16 plus 8, so that's equal to 24. So again, step 3, I want pins 3 and 5 on. And then step 4, I want pins 2 and 5 on. And so I can just do that conversion. So now I have step 1 is just 20, then 24. Step 3 is 40 and 36. So these are the commands to turn which pins on. And so now I don't have to use the digital writes. I can just, in one step, command the position. So you can see down here in my function, I can just say, instead of saying digital write, I say port D equals, and I say step 1, and that does the conversion for me. And it'll turn those, using that binary number, or the value from decimal to binary, to turn pins 0 through 7 on or off, according to that number. So step 1, 2, 3, 4. If I want to go backwards, I go step 4, 3, 2, 1. And then when I want to turn the motor off, well, I have an off command, and all the off command is just saying, like, well, all the pins are off, so there's zeros, so that's just a value of 0. So off is 0. In order to, another quick thing is, instead of saying pin mode, where I have to say pin mode and give it the pin and say that it's an output, I can say instead of port D, I can use the DDRD function to command pins 0 through 7 to be either inputs or outputs. So 0 means input, 1s mean output. Oops, I didn't mean to move that. And so I'm making this 4 pins outputs. So pins 2, 3, 4, 5. So again, in one step, I can command all the pin modes, and then in one step, I can command all the pins to be either on or off, high or low. In this code, what I've done is now my delay, I went back to milliseconds. Sorry to be confusing. I thought, okay, enough with the microseconds. If I have a delay of 1 millisecond, that's what I had last time. So the speed, rotating 2 rotations, should be the same. But I thought, let's slow it down. Let's show it at different speeds. So if I slow it down to a speed, if I double the weight in between pulses, then it should be half the speed. And if I quadruple the weight in between pulses, then it'll be quarter speed. And if I multiply by 8, then it should be 1/8 speed. So this should rotate twice clockwise at full speed, twice clockwise at half speed, then twice again clockwise at quarter speed, and then twice counterclockwise at 1/8 speed. So I'm going to turn off my power supply real quick so we can just upload the code without having it run, so I can turn the camera on. All right, so it's done uploading. So I'm going to go back to full camera here. The code is probably done, maybe not. If I plug it in, if it moves, we'll see. All right. So now I have to do, because it was in the setup loop, the void loop was doing nothing. It's just waiting me for a hit reset, and it'll run the setup again. So again, twice full speed, then twice half speed, then quarter speed, then 8 speed. Okay, so now you can see that pretty simply I can control the position by telling it how many steps to move, and the speed by controlling the delay. this is nice. I want you to understand how stepper motors work. That's all you're doing is turning on and off different coils with wait times in between, and that gets you the speed. However, like everything else in the Arduino, there's libraries, right? So inside your default Arduino, you have to select Arduino Uno for this to show up. But if I go to examples, you see here where it says examples for Arduino Uno. Under here, there's a stepper, and you can select these default codes to learn how to use this. I've kind of used that code from this library. Again, I got to change this. And so the motors wire the same, but now using the stepper library, I don't have to do the commands. I can let the library do it for me. So again, I want to go 2 rotations. I have to tell it how many number of steps per revolution. And then using the stepper library, I create a stepper motor called myStepper, and I can call this Bob if I want to, right? If I want my stepper motor to be called Bob, that's fine. But the default's like myStepper. I tell it how many steps per revolution, and then I to give it the pins. It's pins 2, 3, 4, 5. Then with this, I can in the setup, I can set the speed in the RPM, and doing that sets the delay time between steps. So if I want to say 240 revolutions per minute, and then I tell it to step, so 2 rotations times 200 steps per revolution, so it should rotate twice. Then pause for a second, and then I change the speed to be half speed, and then I'm going to rotate twice in the negative direction. And then because I've learned port D, I'm just going to use this, and you can see you can give it the binary value if you want. So it's 2, 4, 6, 8. There's the 0 through 7 pins, given the binary number, and that'll turn all the pins off. And that way it doesn't heat up the motor. So let's upload this. I'm going to turn off the power supply so it doesn't run yet. And let's upload this. Okay, it's done uploading. And let's see here. Sorry, I was just covering, make sure I covered everything. Okay, I'm going to go to the camera. So again, it should rotate twice at full speed and then twice in counterclockwise direction at half speed. And I believe that is, oh, I got to minimize my camera here. Yeah, I believe that's in the setup, so it only should do it once, so that's right. Okay, so it's waiting for me to press the reset button. So here I go. Let's get it set on there. There's enough slack in here that it's been worn out, so we'll just do our best. Twice, and then half speed. So there you go. So pretty simple method of controlling a stepper motor using the stepper motor library. Again, so now you understand what the principles are behind this, that all you're doing is you're telling it how many steps, and the speed here is just really changing the delay time in between the steps. So let me just double check I've covered everything here. Okay, I think that's everything I want to include in this first video. Again, I hope this helps you understand, one, how you can maybe go about purchasing a stepper motor, knowing what you're purchasing, how to choose it, and then maybe how to start learning how to control it. Next video, we'll go over some limitations of stepper motors, and then I'd like to also show you a fancier stepper motor driver. Thanks.